Hello everyone, I'm thrilled to showcase our AI based water level detection system, a solution designed to intelligently monitor water levels, predict them accurately, and alert us when thresholds are reached. Let's see the system in action. As I pour water into this tank, the ultrasonic sensor will measure the water level in real time. You will see the distance values decreasing continuously on the LCD display. Once the distance drops below 5 centimeters, the buzzer will start beeping, alerting us that the tank is full. This simple yet effective system demonstrates how we can efficiently monitor and manage water levels for various applications. This code is for a water monitoring system integrated with a neural network to learn and predict water flow levels. It utilizes components like an ultrasonic sensor for water level measurement, an LCD for displaying information, and a buzzer for notifications. The neural network trains on predefined patterns to model water flow behavior. Let's dive into how each part of the code contributes to this system. First, let's understand how the sensor data is collected. The getDuration function is the heart of this process. Here's how this works. When the system starts, the ultrasonic sensor sends out a pulse using the trick pin. This pulse travels through the air, hits the water surface, and reflects back. The sensor then captures the time it takes for the echo to return using the echo pin. This duration is critical because it directly correlates to the distance of the water from the sensor. In our system, we use the first reading from the sensor as a baseline measurement, called init duration. This value represents the water level when the tank is initially empty, and it helps us calculate the percentage of the tank's fullness later. Once we have the sensor reading, the simple measurer function takes over. This function calculates the water level percentage by comparing the current sensor duration to the baseline. For example, if the current duration is half of the baseline, it means the tank is 50% full. We display this percentage on the LCD screen along with a status message like full, empty, or filling, depending on the situation. And here's the handy feature. When the tank reaches full capacity, a buzzer goes off to alert the user. This makes the system practical and user friendly. Now let's talk about the loop function. This is where everything comes together. In the loop, the system waits for user input through the serial interface. The user can choose between two modes. Training mode, where the neural network is trained on predefined patterns of flow. Driving mode, where the trained network predicts real-time water flow levels. Depending on the input, the system either starts training the neural network or applies the trained model to make predictions. It's a dynamic interaction that ensures the system can adapt to different needs. The real magic of this system lies in how the neural network is trained and tested using the train-NN and drive-NN functions. Let me guide you through this exciting process. The train-NN function teaches the neural network to recognize water flow patterns by processing randomized input data through forward propagation, where neurons apply a sigmoid function to generate outputs. It compares these outputs with expected results, minimizes errors using propagation, and fine-tunes the model until the error is low or iterations are complete. The result is a trained model ready for accurate predictions. Once trained, the drive-edit function puts this learning into action. It uses live sensor data to predict water flow by processing it through the same layers. Together, these functions make the system both adaptive and intelligent. In conclusion, this system beautifully integrates Sensor-based monitoring with machine learning. The ultrasonic sensor measures water levels, the LCD displays real-time information, and the neural network adapts to predict water flow behavior. It's efficient, adaptive, and practical, a great example of how technology can solve real-world problems. Thank you.